All right, thanks. So I'm Chris Smith. I'm a software engineer at Rethink Robotics. If you don't know Rethink, we were started in 2008 by Rodney Brooks. We make the Baxter and Sawyer robots. They're typically sold into manufacturing environments to do stuff like machine tending, PCB testing, inspection. And so what am I talking about? I'm going to give some very heavily abridged histories of ROS and Rethink, talk about kind of why we decided to eventually build rosnodejs. We're going to go through some code examples, just like looking at basically how you interact with it, do a brief kind of comparison with the ROS CPP client library, and then have some demos and talk a bit about limits and kind of future work that still needs to happen. So this is a very abridged history of ROS, obviously. It's kind of a web tech focused one. ROS obviously started a little before this, but June 2009 was the first paper published on ROS as far as I'm aware. You then have the original ROS Bridge paper from Chad Jenkins' group that came out a few years later. Actually discovered after we had written rosnodejs that someone at Willow had worked on one for a while ago. And then a bunch of stuff going on robot web tools, but not a ton has kind of happened in the space that I'm aware of. If you did something cool and I don't have it on here, I'm sorry, but I'm not aware. And at Rethink, I was actually very surprised to learn that we pulled ROS in 2010. This was apparently Box Turtle. I'm surprised, but it's still with us. So when I joined Rethink in 2014, this is roughly what our software looked like. It's all running on the robot's head display. All the interaction is through buttons on the robot. This is the software that Sawyer, the second robot, launched with. And kind of a high-level goal of the software we build at Rethink is to make it easier to actually deploy robots in manufacturing environments. And in some respects, the software did that really well. But there were also some issues. A big one for us was just that while it was easy for people to get the robot to do simple things, it was hard, if not impossible, for them to get the robot to do more complex things. So it was kind of a low floor, but also this low ceiling. And there were a bunch of reasons for this. One of them was our sort of arcane task structure, which generally made it difficult for users to reason about what the robot was going to do. It was hard for them to alter default behaviors, and then it was hard for us as software developers to write code that would look at a task and try to understand what it was going to do. So in February, actually, we released Intera 5. If you're aware of Rethink, you've probably kind of seen this before. The UI is running inside of Chrome, and the task representation is now using behavior trees, which is common in like video game AI and I think a few other areas. But roughly, our tech stack is this. So there are multiple UIs that are all running in Chrome or Chrome that are connected to this thing that we call the engine that's written in Node.js. The engine is then kind of communicating to the robot, like doing the controls and I/O, which is then talking to all the embedded stuff. And the engine is this very big thing that kind of does all this, but the important piece of it for this talk is really that it is a software interface to the robot. If you've used the SDK on Baxter at all, the engine functionally hooks into the SDK. And so that communication is over ROS. When we first started doing this, we were using ROS Bridge to connect to the rest of the engine, or connect the engine to the rest of the robot, which worked really well for a long time. It's very easy to get going. We immediately had communication to the front end and the back end, which was pretty nice. If you don't know what ROS Bridge is basically the server written in Python that communicates over ROS on one side and then has this custom JSON WebSocket protocol on the other. I think it was initially just kind of intended for browsers, but it's been extended to other environments, so it definitely runs in Node, and I think I've seen it used in Java and MATLAB and a few other places. But we kept running into issues. I think dealing with large amounts of data being sent over ROS Bridge has been something that they've been dealing with for a long time. I know they've come up with a lot of things to try and improve that, like BSON encoding, the web video server. the TF2 web republisher. A lot of them work very well, but we kept kind of having issues with the amount of data that we were sending through. Generally, we'd run into bugs where data would kind of be buffering in ROSBridge and then either wouldn't get out of the engine to the robot. So if somebody told the robot to stop, the robot wouldn't stop. Or vice versa, data coming from the robot would be really slow to display to the users. So sometime in early 2016, I started thinking about experimenting with writing ROS into Node. And in February of that year, I sent this email to Ian McMahon, the head on our SDK, which was basically ROS running in Node. Everything didn't fully work at this point, but all the communication was there, the message generation was there. Before pulling it in, we wanted to do some testing. This isn't the testing that I did then. I couldn't find it, so 2 weeks ago I roughly tried to recreate it. But we ran some tests just trying to publish and subscribe, sending lots of messages across. So these are the publishing tests. We had similar ones for subscribing, but it generally looked to us, and this wasn't what we were looking at the time, but like rosnodejs was performing better than ROSBridge and roslib.js, which should be expected because we're cutting out this middle step where it has to deserialize and reserialize all the data. So in September of 2016, we pulled rosnodejs into Intera and pulled ROSBridge and roslib out of our system. But what can you do with rosnodejs? I think nearly everything that the ROS core can do. So there's publishers, subscribers, services, parameters, actions, namespacing, some simple time stuff, logging, message generation. Node files can also be executable, so you can ROS run or ROS launch them. So if we just wanted to initialize a node, can I get a pointer? There we go. It looks very similar to other initializations that you've seen. You just pass in a string for the node name, and then there's a bunch of options. So you can make your node anonymous. You can programmatically overwrite the ROS master URI if you want to. There's a bunch of other things. You can then just shut down the node. You can hook into events for when the node is told to shut down. We have node handles, mostly because I missed them in ROSPy. Node handles kind of generally broker any attempt to do topic, service, or parameter interaction. You can give it a namespace too, which is nice. So if you're going to subscribe to like 20 topics and they're all deeply nested in some namespace, you can just give your node handle a namespace and not deal with copying that over and over again. So if you wanted to make a publisher, you would just do it through the node handle. You pass in a topic, which is a string, a type, which is either a string or an object, and then there's a bunch of options to set the queue size and latching and stuff like that. So if you're going to make a publisher, you just set the topic. The type can be a string, which just says standard messages / string, or if you want to instead, you can actually pull in the message that you're trying to use and just pass that object in, pass in overrides. When you're actually publishing, you can give us just a raw JavaScript object, or you can actually create a string message and publish that instead, and then you can shut down each of them. Subscribers are fairly similar, except they have a callback. So here we just made a callback function, and then topic, type, callback, kind of the same thing, except we're again using the object to specify the type. Again, you can specify options, and then what we're actually doing under the hood when you add a callback here is we're just hooking it into this message event, so if you don't give us one when you actually create the subscriber, you can just add it whenever you want to and remove it as you need, and then you can shut them all down. Services, which you can advertise and make clients do. So your callback function for this looks a little bit different than the subscriber. It has a request object and a response object, which will be filled in with the data that you need in the request, and then you just fill in the response. And then, again, you pass in the name of the service that you're going to send, the object or a string for the type, and then the callback function. The service client, you also just instantiate, and then you can call it with a request. The node handle also exposes a function to wait for services if you need them. And then parameters, I think this technically isn't everything that you can do with parameters, but I've never seen anybody use the other parameter functionality, and nobody's asked me for it, so I haven't done it yet. If you want it, let me know. But you can get, set, check, and delete parameters, so it's most of it. There is logging. You can hook into the logger if you want to kind of send the data somewhere else. But by default, it will log to standard out, standard error, and ROS out. There's throttled logging, and you can set and get log levels as you need. And then a simple time interface to give you either the sim time or the wall clock time as appropriate, and then some helper functions to convert between JavaScript time representations and ROS time representations. Messages, there are a lot of options and can be a little confusing, but generally if you're running in Kinetic or later in a Catkin workspace, they'll just exist for you. They'll get built with all of your other messages, and you can just pull them in whenever you want through this require function that rosnodejs exposes. And then you can get messages and services from them. If you're running in Indigo or earlier, which we are, which is why this exists, you can have them built for you. They'll also just be put into your devel workspace. And then actually kind of someone pulled in from Brandon Alexander's early stuff, I think. You can just generate the messages on the fly if you prefer. The messages themselves provide constants. If you instantiate them, they'll automatically have default fields filled in for everything. So this is obviously not going to actually compile, but roughly in ROS-CPP, this is sort of a intranode chatter example. So if we wanted to compare this to what it would look like in rosnodejs, it would actually be very similar, which I think is really cool. So you can see right at the top, we're pulling in the packages that we want to use, both just ROS and the messages that we're going to use. We then initialize the node. We create a node handle. We make a callback that's just going to take in the message and log something. We'll advertise a publisher on a topic with a type. You create a subscriber on the same topic. And then you create a message, give it some data, and then once a second, you'll just publish a message on that topic. So what does this look like? We have some very simple examples. So I'm just running a ROS core here. Here I'm running a talker. That's very similar to all of the kind of ROS talker examples. I can make a listener, and here it's getting data. You can obviously echo that topic also if you want to. If you're curious about adding two integers together, and for some reason you just can't figure it out on your own, there is a server that can do that for you. And now you have done some very complicated math, so you're welcome. I think the biggest example I'm aware of is in Terra. So this is in Terra 5. I made the robot do some very strange pattern task. This is just our UI, which is running in Chrome. So obviously, rosnodejs is not running in Chrome, but the web page is connected to backend that is running in Node.js, and so all of the data from the robot is funneled up in real time. Well, not real time, but to the UI to let you see what the robot's doing and what the behavior tree is doing as it runs. And then the other example is this very hacky RViz that we made a year-ish ago during a quick hackathon. We were mostly trying to explore using Electron and then also testing out some different re-architecting of our 3D view stuff going on. Electron, if you don't know it, is this really cool open source package from GitHub. It powers their Atom code editor, which is a code editor from GitHub, but Electron lets you build apps in Node.js. It's this combination process with a Node backend and a Chromium frontend, but they're all running in the same process, and Electron will automatically build those for you into native apps to run on Mac, Windows, or Linux. But the front end in Electron also has access to all of the file system and kind of native APIs that browsers generally don't give you access to. I don't know where the light came from in this, and Baxter only has one arm, but the TFs look pretty good. It's a hackathon. So what can't you do? So JavaScript number representation, all numbers in JavaScript are represented as 64-bit floating point numbers, so there's no 64-bit integers natively supported in JavaScript. There are a host of packages that you can pull in that provide that support for you, so that's what we do, although there are proposals to add native big integer support. Generally, JavaScript time resolution only gives you millisecond precision. If you're running just in Node, you could write plugins to C++ that would give you higher resolution stuff, but it wouldn't scale to the browser or necessarily to other backend engines. And then obviously, rosnodejs cannot run in the browser. You're still going to need a bridge, which could very reasonably be rosbridge and roslib. Ours kind of ties into our own event system that we use for everything else. In terms of future work, I think there's a lot more to do on tools and utilities to run in JavaScript, TF, URDF, math stuff. Ideally, these would be platform agnostic. We could tie into like a lot of KDL, C++ stuff to run it in Node, but then it wouldn't be able to run in the browser. And that would probably be annoying in some instances. roslib.js already has some of these, but a number of them kind of tie into the roslib's communication protocol. And then RCL Node.js is actually being developed, I think, by Intel for ROS2. So depending on how they build it and what changes between ROS2 and normal ROS, we could possibly share some of those tools and utilities. But that's it. So if you're interested in the code, it's online, it's open source. You can open pull requests and file bugs as you want. Ian is looking for an intern. You can talk to him if you would like.
Thank you. We've got time for just a question or two, if there are. And Justin, come on up. While people are thinking about that, are you looking for contributions to rosnodejs? And if so, what do you need help with?
I think rosnodejs, there are certainly a few things that we're missing. I mentioned a few parameter things that we don't support. I don't think we have topic remapping yet. And then I think there's still some more testing to do on a lot of the action stuff. I mostly had to parse through all of the action lib source code to try and figure out what the action server and stuff we're actually doing. So I don't think that's probably that solid. I think a lot more of the work is building tools and utilities to use in JavaScript. But we're working on that too.
Yeah. Do you have any plans for TypeScript support or TypeScript types with it?
No. If you want to do that, you should. Yeah, I wouldn't have a problem doing it, but we don't use TypeScript, and so I didn't. Yeah.
All right. Thanks, Chris.
Yep.